There, welcome to Pomodoro Joe for Sunday, October 15th, 2023. Today we're doing LeetCode problem 1269, number of ways to stay in the same place after some steps. This is another hard problem. Man, October is just hard problem month. All right, what do we got? You have a pointer at index 0 in an array of size array length. At each step, you can move one position to the left, one position to the right, or stay in the same place. The pointer should not be placed outside the array at any time. Given two integers, steps and array length, return the number of ways such that your pointer is still at index 0 after exactly steps. Since the answer may be too large, return it modulo 10 to the 9th plus 7. Okay, so we're given an array, but we actually aren't given an array. What we're really given are steps, which is an integer, and the array length, which is an integer. So we just know how long the array would be if we actually had a real array. Now our goal is to see how many ways we can take number of steps, but still end up at index 0 at the end. Now at each step along the way, we have three options. We can move to the left, we can move to the right, or we can stay in the same place. Now at any point, we can't move outside the boundaries of our array, so we can't go below 0 or above this array length. So those are our constraints. And then we have some additional constraints. Let's say steps is between 1 and 500, and the array length is between 1 and 10 to the 6th. Okay, so this actually doesn't seem that bad. All right, we'll put 25 minutes on the Pomodoro timer, and we will get started. Okay, so I think we'll just do this the very straightforward way. We'll have a recursive function. We'll just go through and we'll try all of our options. Option 1, we step to the left. Option 2, we step to the right. Option 3, we stay in the same place. Then we recurse and just see how many ways we can end up back at 0. Okay, so let's have a recursive function. Def num ways recurse. Okay, so for this one, we'll need to know how many steps we have left. So I'll just call that S. And then I'm going to keep track of our position. Where are we in this array? So steps and position. Cool. All right, what's the first thing we always do with a recursive function? I didn't hear what? What was that? Okay, we write the base case. So let's write the base case. What's the base case here? I guess we might have a couple base cases, but we'll start with the first one. If S is equal to 0. If S is equal to 0, we are out of steps. Now let's check. What position are we at? So let's see, we'll return 1 if our position is equal to 0 as well. Otherwise, we'll return 0. So that's just another way of saying we're out of steps. Steps is equal to 0, and we're at position 0, meaning we had one answer to our solution. All right. And then if we're not at position 0, that means we're out of steps. We're not going to get to position 0. We return 0 because that means we didn't find an answer to this problem. Okay, so that's our base case. Now let's look at all of our options. We have option 1. We'll step to the left. All right, so let's see. We might not be able to actually step to the left, so I'm going to just keep track of this here. Option 1 will start at 0. Now, are we able to step to the left? So let's see. Check to see if our position is greater than 0. Then we can step to the left. So then option 1 becomes, well, let's take that step. So it's going to be number of ways recurse. And since we're using one step, it's going to be step minus 1. And since we're moving to the left, it's going to be position minus 1. So we just took a step from our current position, P, one step to the left. So that's going to be P minus 1. Okay, that's our first option. Let's check option 2. Option 2, let's step to the right. Okay, and again, we're going to have to check our bounds. So let's say option 2 is equal to 0. And then if our P is less than some max index or max position, then we can take this step. So option 2 will become number of ways recurse. Again, this is taking a step, so it's step minus 1. But now we're stepping to the right, so it's going to be position plus 1. And then finally, option 3, we stay put. Okay, now for this option, we don't need to check our bounds. So we can just do a straight call here. Number of ways recurse. This takes one step, but we're not changing our position, so we stay at position P. Cool. Now I didn't actually create this max index, so let's do that now. So the max index is array length minus 1. It's a 0-based array, so array length minus 1 is our max index. All right, let's see. Now, finally, so that takes care of option 1, option 2, and option 3. Now we return the total of our options. Option 1 plus option 2 plus option 3. And then we do need to return this modulo 10 to the 9th plus 7. So let's do modulo, I'll just call it mod value here. And then I'll create a mod value out here. Mod val is just 10 to the 9th. So it's 10 star star 9 plus 7. All right, so that takes care of our recursive function. Let's kick the whole thing off with our initial call. So number of ways recurse with number of steps. So it's just steps. And we don't pass in the array length because we're just using that for our bounds checks, and we'll say we're at position 0. Cool, so I think this is it. All right, so we've got our max index, which is the array length minus 1. We've got our mod value, 10 to the 9th plus 7. Then we have our recursive function. We have our base case. If we are out of steps and we're at position 0, we'll return 1. That was one solution. If we are not at position 0, we'll return 0. All right, otherwise we have 3 options. So option 1, we step to the left if we can. So we check our bounds first. If we can step to the left, we'll take 1 step and we move our position to the left. Option 2, we step to the right. Again, we have to check our bounds. If we can, we'll move 1 step and we'll move it to the right. And finally, option 3, we take a step, but we stay in the same place. At the end, we just sum all of our options. Those are all the different ways we can end with a position of 0 and 0 steps. And then we return that mod, our mod value. Cool, let's just see if this works. Okay, that seems to work. Now I already know that this is probably going to be too slow, so since we have simple inputs here, let's automatically just add our cache at the beginning here. Cool, let's see if that still works. It still works, so let's submit this and see how we do. And we pass. So in terms of hard problems, this one actually isn't that bad, and we do okay. We beat 56% for runtime and 31% for memory, so that's not too bad. It's not great, but it's not too bad. Now we could do a couple things. Let's see what we could do. So one super simple thing we could do is instead of having this option 1, option 2, and option 3, we can just have a result out here. So we'll just have result, and that equals 0 to start with. Instead of having this option 1, we'll just add result. So result plus equals. And then same thing, we don't need this option 2. We can just use our result. And finally here, result. And then we just return result mod, our mod value. Cool. All right, this should save us a little bit. Let's see. Not really. Let's see, we went from a 56. All right, so that just saves us a tiny bit. We go from a 56% to a 58% runtime and no change in our memory. So that's a little bit better. All right, if you solve this one, you can always jump in here and check out how other people solved it. They're doing something a little bit different. So yeah, check this one out. Very compact solution here. Yeah, a lot of people doing this. Wow. Well, there are definitely faster ways to do this than what we did, but I like solving it this way because it's clear what we're doing. Okay, well that is it for me. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.